Sir Isaac Newton's 3 laws of motion form the cornerstone of classical mechanics, providing a comprehensive framework for understanding the motion of objects. Newton's first law, often referred to as the law of inertia, posits that an object at rest will remain at rest, and an object in motion will continue moving in a straight line at a constant velocity unless acted upon by an external force. This fundamental principle challenges our intuitive understanding of motion and lays the groundwork for subsequent laws. Moving on to Newton's second law, it introduces the concept of force as a factor influencing an object's motion. The law mathematically states that the force acting on an object is equal to the mass of the object multiplied by its acceleration. This straightforward equation, F equals ma, forms the basis for calculating the impact of forces on objects of varying masses, providing a quantitative understanding of the cause and effect relationship between force and motion. Newton's third law, often encapsulated by the famous phrase action and reaction are equal and opposite, delves into the interplay of forces between interacting objects. When one object exerts a force on a second object, the second object simultaneously exerts a force of equal magnitude but in the opposite direction. This law elucidates the reciprocal nature of force interactions, shedding light on the intricacies of motion in dynamic systems. The applicability of Newton's laws extends far beyond theoretical physics, permeating various scientific disciplines and real-world scenarios. From the motion of celestial bodies to the mechanics of everyday objects, these laws serve as invaluable tools for understanding and predicting the behavior of the physical world. Moreover, Newton's laws laid the groundwork for the development of classical mechanics, inspiring subsequent generations of physicists to refine and expand upon these principles. While Einstein's theory of relativity and quantum mechanics have broadened our understanding of the universe, Newton's laws remain indispensable for describing the motion of objects within the realm of classical physics. In conclusion, Newton's laws of motion represent a pivotal milestone in the history of physics, providing a robust framework for comprehending the fundamental principles governing the motion of objects. From the simplicity of the first law to the mathematical precision of the second law and the nuanced interactions described by the third law, these principles continue to shape our understanding of the physical world and remain essential tools in the physicist's toolkit.